Far beyond Earth, past Mars and the asteroid belt, there is a world covered in ice that may hold one of the greatest secrets in the universe. It is not a planet. It is a moon orbiting the largest planet in our solar system, Jupiter. Its name is Europa. At first glance, Europa looks lifeless. A frozen sphere, wrapped in ice, cracked like shattered glass. No trees, no oceans on the surface, no blue skies, only silence and ice beneath the blackness of space. But underneath that frozen shell, scientists believe there is something extraordinary. An ocean, a global ocean, deeper than any sea on Earth, kept warm not by sunlight, but by the invisible pull of Jupiter's gravity. For decades, scientists wondered if life could exist somewhere else in our solar system. Many believed Mars was the best candidate, but now, more and more eyes are turning toward Europa. Because where there is water, energy, and chemistry, there could be life. This is not science fiction. NASA, the European Space Agency, and research teams around the world are building spacecraft right now to travel across millions of kilometers of space to explore Europa. Their mission is simple but breathtaking: to find out if we are alone in the universe, or if life could be swimming in the dark oceans of a distant moon. Imagine standing on Europa's surface. Above you, the giant planet Jupiter fills the sky, striped with storms and swirling clouds. Lightning flashes across its atmosphere. Its powerful radiation crackles invisibly through space. The ground beneath your feet is ice, stretching as far as you can see, smooth in some places, broken and jagged in others like frozen waves. Beneath that ice could be a world of complete darkness, where no sunlight has ever reached. But it might not be silent. There could be currents, tides, underwater volcanoes releasing heat and minerals, and perhaps, just perhaps, something alive. This documentary will take you on a journey to Europa. We will uncover what scientists know, what they do not know, and what they hope to find. We will explore how Europa was discovered, why it could support life, and how future missions will try to land on its frozen surface and search its hidden ocean. This is the story of one of the most mysterious worlds in our solar system. This is the journey to Europa. Could the ocean moon hide alien life? Europa was discovered more than 400 years ago, in the year 1610, by the Italian astronomer Galileo Galilei. He aimed his small telescope at Jupiter and saw 4 points of light orbiting around it. These were the first moons ever discovered beyond Earth, now known as the Galilean moons. Europa was one of them. For centuries, it was just a moving point of light in the night sky. No one knew what it looked like, or what mysteries it held. That changed in the 1970s when the Pioneer and Voyager spacecraft flew past Jupiter and sent back the first close images of Europa. What they saw was surprising. No mountains, no craters like the Moon or Mercury. Instead, Europa looked smooth, pale, and covered in what scientists believed was solid ice. Later missions confirmed this. When NASA's Galileo spacecraft orbited Jupiter in the 1990s, it flew past Europa many times. It measured gravity, magnetism, and surface composition. The evidence became clear. Beneath the ice was a vast global ocean, kept liquid by tidal forces from Jupiter. Europa is now believed to hold more water than all of Earth's oceans combined. This discovery changed everything. Scientists realized that if Europa has liquid water, energy, and the right chemistry, then it could also have life. Not complex life like humans or animals, but simple life, like bacteria or tiny organisms living in the ocean's depths, similar to life near hydrothermal vents on Earth. Europa is about 3,100 kilometers wide, just slightly smaller than Earth's moon. Its surface is one of the smoothest in the solar system. This smooth ice is marked by long, dark lines called lineae. These cracks stretch for hundreds of kilometers. They are believed to be caused by the ice crust breaking and shifting as the ocean beneath moves, and tides flex the surface. In some places, reddish-brown material spreads across the ice. Scientists think this could be salt, or minerals from the ocean below, pushed to the surface through cracks. If this is true, then Europa's surface could contain clues about the chemistry of its hidden ocean, and possibly traces of life. Europa orbits Jupiter every 3.5 Earth days. It is locked in place by gravity, which means one side always faces Jupiter, just like our moon always shows the same face to Earth. Jupiter's gravity pulls on Europa's ocean, causing tides that stretch and heat the moon from within. This process is called tidal heating, and it keeps the water from freezing solid. The surface of Europa is extremely cold, around -160 degrees Celsius. There is no air to breathe, and radiation from Jupiter's magnetic field constantly bombards the surface. It is deadly for humans. Yet beneath the ice, the water is shielded from radiation, and the ocean could be warm enough and rich enough for life. Europa is not just another moon. It is one of the most promising places in the entire solar system to search for alien life. Not in the distant future, but within our lifetime. Beneath Europa's frozen crust lies a world no human eye has ever seen. A silent ocean stretching across the entire moon, deeper than any ocean on Earth. Scientists estimate that this ocean may be between 60 and 150 kilometers deep. In comparison, Earth's oceans only reach about 11 kilometers at their deepest point. Even though Europa is much smaller than Earth, it may contain more than twice as much water. This ocean does not touch the sky. Instead, it is trapped beneath an ice shell that may be 15 to 25 kilometers thick. The surface is frozen, but under the pressure of Jupiter's gravity, the interior remains warm enough for liquid water. The ice above acts like a shield, protecting the ocean from radiation and space. It creates a hidden sea in complete darkness. So how do scientists know this ocean exists if no one has ever seen it? The answer lies in evidence gathered by spacecraft. When NASA's Galileo orbiter passed Europa, it detected magnetic disturbances. These could only be explained if Europa had a layer of salty, electrically conductive water beneath its surface. Gravity measurements also showed that Europa's interior was not solid. It behaved like a world with a liquid layer. Scientists also observed the strange movement of Europa's icy surface. The cracks, ridges, and chaotic terrain suggest the ice is floating on water, or soft ice. In some areas, the surface looks like broken icebergs that have drifted, rotated, and frozen again. This process is almost impossible without a liquid layer beneath. One of the most exciting discoveries came in 2012, when the Hubble Space Telescope detected what appeared to be plumes of water vapor erupting from Europa's surface near the South Pole. These plumes, if confirmed, would mean that water from the subsurface ocean is bursting through cracks in the ice and spraying into space like geysers. Similar plumes have been seen on Saturn's moon Enceladus. If Europa truly has plumes, future spacecraft could fly through them and test the water for organic molecules, salts, and even signs of life, without drilling through the ice. This would be one of the most important scientific experiments in human history. But what could the ocean itself be like? Imagine a vast, dark sea, heated from below by hydrothermal vents on the seafloor. On Earth, such vents are home to entire ecosystems, where bacteria, tube worms, and strange creatures survive without sunlight by using chemical energy. If Europa has similar vents, they could provide energy and nutrients for life. To understand whether life could exist in Europa's hidden ocean, scientists ask a simple question. What does life need to survive? On Earth, life depends on 3 essential elements: liquid water, a source of energy, and the right chemical ingredients. If all 3 exist on Europa, life becomes more than just a possibility. Europa clearly has liquid water. More water than Earth. But water alone is not enough. Life also needs energy. On Earth, most life uses sunlight as energy through photosynthesis. But Europa is far from the sun. Sunlight there is almost 1/25 as strong as it is on Earth, and no light reaches the ocean beneath the ice. So if life exists, it must feed on chemical energy. This is where hydrothermal vents come in. Deep on Europa's ocean floor, the rocky mantle might interact with water, producing heat and minerals. Just like on Earth, Chemical reactions between water and rocks can produce hydrogen, methane, and other energy-rich molecules. Even without sunlight, bacteria could survive on these chemicals. Scientists call this chemosynthesis. Earth has extreme places that give us clues about Europa. In the darkest parts of our oceans, near hydrothermal vents, entire ecosystems thrive without sunlight. Giant tube worms, shrimp, and millions of bacteria live on chemical energy from the vents. Life is also found under glaciers, in frozen lakes in Antarctica, and in acidic hot springs. These environments teach us that life does not need perfect conditions. It only needs opportunity. The third requirement for life is chemistry. All known life is based on carbon and uses elements like hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Scientists believe these elements exist on Europa. The surface shows signs of salts and minerals, possibly carried up from the ocean. Observations suggest the ice contains traces of carbon compounds, though their exact origin remains unknown. Another vital ingredient is time. Life on Earth took hundreds of millions of years to evolve from simple molecules into living cells. Europa has existed for billions of years. Its ocean may have remained liquid for most of that time thanks to tidal heating. If life began there early and conditions stayed stable, it might have had time to evolve. But Europa is still a harsh world. The ocean is locked under ice. Radiation from Jupiter constantly bombards the surface, destroying organic molecules. The ocean might be too salty, too acidic, or lack enough energy. Life, if it exists, may be rare and simple, nothing like animals, fish, or intelligent beings. Still, the possibility of even simple life is profound. If life developed on both Earth and Europa, it means life could emerge wherever conditions are right. It would suggest that the universe is full of living worlds. The question is no longer just scientific. It is philosophical. If we find life on Europa, what does it mean to be human? Are we alone, or are we part of something much larger? That is why missions are being sent to Europa. To answer these questions not with theories, but with evidence. To explore, to test, and to discover the truth hidden beneath the ice. However, Europa's ocean might also be harsh. It could be very salty, acidic, or full of dissolved minerals. The pressure would be enormous because of the weight of the ice above. There would be no light, no sky, no seasons. If life exists there, it would have to be strong, simple, and adapted to darkness. Still, Earth has taught us that life can survive in extreme places. In deep caves, under glaciers, inside rocks, and at the bottom of oceans. Life finds a way. If it can happen on Earth, maybe it can happen on Europa too. This hidden ocean is why Europa has become one of the most important destinations in the search for alien life. To find life, we do not need to travel to another star. It might be waiting beneath our feet on a moon that orbits Jupiter. To understand whether life could exist in Europa's hidden ocean, scientists ask a simple question. What does life need to survive? On Earth, life depends on three essential elements: liquid water, a source of energy, and the right chemical ingredients. If all three exist on Europa, life becomes more than just a possibility. Europa clearly has liquid water. More water than Earth. But water alone is not enough. Life also needs energy. On Earth, most life uses sunlight as energy through photosynthesis. But Europa is far from the sun. Sunlight there is almost 1/25 as strong as it is on Earth, and no light reaches the ocean beneath the ice. So if life exists, it must feed on chemical energy. This is where hydrothermal vents come in. Deep on Europa's ocean floor, the rocky mantle might interact with water, producing heat and minerals. Just like on Earth, chemical reactions between water and rocks can produce hydrogen, methane, and other energy-rich molecules. Even without sunlight, bacteria could survive on these chemicals. Scientists call this chemosynthesis. Earth has extreme places that give us clues about Europa. In the darkest parts of our oceans, near hydrothermal vents, entire ecosystems thrive without sunlight. Giant tube worms, shrimp, and millions of bacteria live on chemical energy from the vents. Life is also found under glaciers, in frozen lakes in Antarctica, and in acidic hot springs. These environments teach us that life does not need perfect conditions. It only needs opportunity. The third requirement for life is chemistry. All known life is based on carbon and uses elements like hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Scientists believe these elements exist on Europa. The surface shows signs of salts and minerals, possibly carried up from the ocean. Observations suggest the ice contains traces of carbon compounds, though their exact origin remains unknown. Another vital ingredient is time. Life on Earth took hundreds of millions of years to evolve from simple molecules into living cells. Europa has existed for billions of years. Its ocean may have remained liquid for most of that time thanks to tidal heating. If life began there early and conditions stayed stable, it might have had time to evolve. But Europa is still a harsh world. The ocean is locked under ice. Radiation from Jupiter constantly bombards the surface, destroying organic molecules. The ocean might be too salty, too acidic, or lack enough energy. Life, if it exists, may be rare and simple, nothing like animals, fish, or intelligent beings. Still, the possibility of even simple life is profound. If life developed on both Earth and Europa, it means life could emerge wherever conditions are right. It would suggest that the universe is full of living worlds. The question is no longer just scientific. It is philosophical. If we find life on Europa, what does it mean to be human? Are we alone, or are we part of something much larger? That is why missions are being sent to Europa. To answer these questions not with theories, but with evidence. To explore, to test, and to discover the truth hidden beneath the ice. For decades, Europa was a mystery seen from afar. Scientists could only study it through telescopes or from spacecraft that passed by on their way to somewhere else. But now, for the first time in history, missions are being built with one goal: to reach Europa and find out if its hidden ocean could support life. NASA is leading one of the most ambitious missions ever attempted. It is called Europa Clipper. It is scheduled to launch in the year 2024. This spacecraft will not land, but will orbit Jupiter and fly past Europa nearly 50 times. During each flyby, it will come as close as 25 kilometers above the surface. Europa Clipper carries powerful instruments. High-resolution cameras will map the surface in detail. Ice-penetrating radar will send radio waves through the ice to measure how thick it is and locate pockets of water. Magnetometers will study the magnetic field to confirm the depth and saltiness of the ocean. Spectrometers will analyze light reflected from the surface to detect chemicals, salts, and possibly organic molecules. If Europa is erupting water plumes, Europa Clipper will fly through them to sample the vapor. It will search for molecules like methane, carbon dioxide, and amino acids, which may indicate biological activity. The data will help scientists decide whether Europa's ocean could support life. Europe is also preparing a mission. The European Space Agency has built a spacecraft called JUICE, which stands for Jupiter Icy Moons Explorer. It launched in the year 2023. JUICE will study Europa, but will focus mostly on two of Jupiter's other moons, Ganymede and Callisto. Still, it will fly past Europa several times and collect valuable data about its surface and environment. These missions are only the beginning. Scientists dream of landing on Europa. A future mission, still in the planning stage, is called the Europa Lander. Unlike the flyby missions, this spacecraft would touch down on the ice. It would drill a short distance into the surface and collect samples. It would then test the material for organic compounds and signs of life. Landing on Europa is incredibly difficult. The surface is extremely cold. The radiation from Jupiter is strong enough to damage electronics within weeks. The ice is rough and unpredictable. And if a lander digs too deeply, it risks contaminating the pristine ocean below with Earth microbes. NASA is developing strict protocols to sterilize any spacecraft that goes near Europa's ocean. Other space agencies and private companies are also interested. Japan has proposed a mission called LUPEX. Russia and China have discussed joint missions to Jupiter's moons. Private companies like SpaceX could one day provide rockets to carry landers or ice-penetrating robots. Human missions to Europa remain a distant dream. The journey takes nearly 6 years. The environment is deadly. No air, extreme cold, and constant radiation. Yet technology is advancing. If humans one day walk on the surface of Europa, it will be one of the greatest achievements in history. For now, the first step is exploration from above. Europa Clipper and JUICE will reveal whether Europa is truly a world of oceans, energy, and chemistry. They will help answer one of humanity's oldest questions. Are we alone, or is there life beyond Earth? Finding life on Europa will be one of the hardest scientific challenges humanity has ever attempted. The ocean we want to explore is not on the surface. It is hidden beneath kilometers of solid ice. To reach it, we will need machines unlike any ever built. Machines that can land on frozen ground, drill through thick ice, and search for life in a dark alien sea. The first step is landing safely. A Europa lander must slow down from tens of thousands of kilometers per hour to a gentle touchdown on ice. There is no atmosphere on Europa to use parachutes. Instead, rockets and thrusters will be needed to land precisely. Cameras and radar will help choose a safe landing spot, far from cliffs and deep cracks. Once on the surface, the main challenge begins. The lander must collect samples from the ice. The top layer of Europa's surface is dangerous because radiation from Jupiter constantly destroys molecules and breaks down organic material. That means the search for life must go deeper, below the radiation-damaged layer, perhaps 10 to 30 centimeters beneath the surface. One method is to use a robotic arm or drill to scoop ice and place it inside a sealed chamber for analysis. Inside the lander, instruments will melt the ice and test it for organic molecules, salts, and possible biological markers like amino acids or lipids. These tests must be automated, precise, and sterile. But to truly explore the ocean, future missions will need to drill through the ice shell. This could be one of the greatest engineering feats ever attempted. Drilling through 10 or more kilometers of ice in freezing temperatures and low gravity is extremely difficult. Traditional drills would need too much energy and time. Scientists are exploring alternatives. One concept is the cryobot, a heated probe that melts its way downward. It uses hot water or nuclear energy to melt the ice and sink slowly, leaving a communications cable behind. Once it reaches the ocean, it can release a small underwater robot called a hydrobot. The hydrobot would swim through the cold, dark sea, guided by sonar and lights. It would search for hydrothermal vents, mineral-rich areas, or chemical plumes on the ocean floor. It would take pictures, collect water samples, and test for signs of life. Every bit of data would travel back up the cryobot's cable to the lander, and from there, back to Earth. Another possibility is to study Europa's plumes. If water from the ocean is erupting into space, future spacecraft could fly through the plumes and sample the water directly. This method does not require landing or drilling. NASA's Europa Clipper and future missions may attempt this, using special instruments to analyze water vapor, salts, and organic chemicals in the plumes. Because contamination is a major concern, every spacecraft that touches Europa must be sterile. Scientists fear that Earth bacteria could accidentally be brought to Europa and spread into the ocean, ruining any chance of discovering native life. For this reason, missions will follow strict planetary protection guidelines. Spacecraft will be cleaned, sterilized, and tested to ensure no living organisms are on board. Artificial intelligence will also play a vital role. Communication between Earth and Europa takes over 40 minutes for a round trip. Robots will need to make decisions on their own. They will navigate, test samples, avoid hazards, and adjust their mission if something goes wrong. The search for life on Europa will not be finished in one mission. It may take decades, with multiple steps. Flybys to map the surface, landers to test the ice, drills to reach the ocean, submarine robots to explore the depths. Each mission will get us closer to the truth. Whether the answer is yes or no, the question is too important to ignore. If life exists in Europa's ocean, we will find it. If we someday find life beneath Europa's frozen surface, everything changes. Even if it is only a simple organism, a microbe floating in the dark, it would answer a question humanity has asked for thousands of years. Are we alone in the universe? Finding life on Europa would mean life is not unique to Earth. It could exist wherever there is water, energy, and time. It could be in the oceans of Enceladus, the lakes of Titan, or even beneath the ice of distant exoplanets and other star systems. Life would no longer be a miracle of one world, but a natural part of the universe. Scientists would study Europa's life to learn if it is similar to life on Earth, or completely different. Does it share the same building blocks, like DNA and amino acids? Or does it use different chemistry? If it is different, that would mean life began not once, but twice in our solar system. It would suggest the universe may be full of living worlds. But if we explore Europa and find nothing, the mission would still be a success. Knowing that a world with water and energy is still lifeless would teach us that life is more rare and fragile than we thought. It would make life on Earth even more precious. Either answer would change how we see ourselves. Beyond science, there is something deeper. Discovering life on another world would make us rethink religion, philosophy, and the meaning of humanity. It would remind us that Earth is not the center of life, but part of something much larger. And yet, the journey to Europa is not only about finding life. It is a test of our spirit. It is about curiosity, courage, and the human need to explore. Each generation has its frontier. For ancient sailors, it was the open ocean. For the space age, it was the moon. Today, it is the oceans of Europa. The spacecraft being built now will travel for years through space to reach Jupiter. They will fly past storms the size of continents and radiation fields stronger than anything on Earth. They will search for answers buried beneath ice older than any human civilization. One day, humans may follow. They may stand on Europa's surface, looking up at Jupiter's swirling clouds. They may drill into the ice, dive into the ocean, and witness a world untouched by time. And when they look back at the sky, they will see Earth, a tiny blue light hanging in the darkness. This journey is more than science. It is a reminder of who we are: explorers, dreamers, keepers of life in a universe of silence. If Europa holds life, we will find it. If it does not, we will still continue. Because the desire to know, to search, to reach beyond our world is part of what it means to be human. This is Europa. This is the hidden ocean world. This is the next chapter in the story of life. If this journey inspired you, subscribe for more stories of science, space, and the mysteries of our universe. Stay curious. Stay hopeful. The universe is waiting.